In robotic blacksmithing, precision is key, but tracking changes as the metal is formed still remains a challenge. Our solution? A portable 3D scanning rig that uses low-cost, open-source hardware to create a 3D mesh of the object that allows blacksmiths and engineers to track changes over time.
Our design consists of two key components: a rotating disc and a vertical camera mount. The process is simple. Our camera captures a full 360-degree dataset at 3 fixed heights. The disc is embedded with April tags, allowing precise positioning and scaling.
What makes our approach innovative? Well, it's low cost, compact, and open source. It's low cost because it uses parts that can be easily made with a laser engraver or even a 3D printer. It's compact because it's small and it can be moved around and it can be used in any sort of situation. It's open source because it uses open source hardware and software. Our hardware is mostly Arduino and breadboards, and then our software is an open source project called Meshroom, as well as OpenCV and the April tag libraries. So this makes it perfect for everyone from hobbyists to startups to established companies who are looking to get into the 3D scanning game.
While developing our prototype, we faced a number of challenges. On the hardware end, we were limited to the hardware resources provided to us during the hackathon, which meant getting the CNC and laser cutting done in time for us to be able to assemble the final rig that we have as a product in front of you. On the software end, we had to deal with a lot of issues going into scan qualities and converting that 3D model into 2D images and back into a 3D mesh. So we had to play around with stuff like integrated, structured time intervals to take those scans, and a tilt angle with a servo motor to be able to properly view the object from heights, which would be above, below, or at parallel level.
Simulating the robotic blacksmithing process by hand as shown, we were able to provide a useful test case that validates our system and shows that it could work in the real world. Our project's impact is manifold. For starters, in the growing robotic blacksmithing industry, it will allow small and large companies to implement low-cost metrology and quality engineering solutions through 3D monitoring of their blacksmithing parts. Additionally, as the project grows due to its open source nature, it can be implemented in other industries such as traditional manufacturing, where quality and metrology are extremely important. So, this is our solution, fusing the best of open source to bring low-cost 3D scanning to robotic blacksmithing. Thank you for your time and expertise.